Okay, so I see that it wants me to turn everything to cos. Can I turn sine squared into cos squared minus one, or even one minus cos squared? Sorry.
Yep. And what's next?
Should I just expand the brackets straight away?
Yep.
And that'll be 4 minus 4 cos squared theta 2 over 2.
Oops. So it was -4, so it's plus. Okay. What is next?
I think there needs to be a 4 in front of the cos squared.
Yep.
Should I now do... Can I just do 6 cos squared theta over 2 minus 4?
-4.
And should I now type... I'm not allowed to double the entire thing, am I?
No. It's just an expression.
Yeah. Should I have... So 6 times theta over... Is that just like 3 cos squared 2? Or it's 3 cos squared theta?
No.
Okay.
I was expecting this to be something different. 6 cos squared. So we have to change cos squared into... I don't know. Yeah, what? Hold on. Cos squared theta over 2 is equal to 1 plus cos theta over 2. This... I don't want to get too into this. Is this the thing? I think it had something here. These are the formulae, trig identities. Like, there's some weird identities. Kind of reminds you a bit of that. What? I was not aware of this. Okay. So cos squared theta over 2 is the same as that. So 6, 1 plus cos theta over 2 minus 4. All right, what do you get there?
So, do I need to expand the brackets here?
Mm-hmm.
So that'll be... Should I just... Will that be 3...
Mm-hmm.
3 cos theta minus 4?
And yeah, timed by the 1 as well. Oh
So,
yeah, sorry, 3, yeah. So 3 plus 3 cos theta minus 4.
and will the final answer come out to be like 3 cos theta minus 1?
Looks good. 3 cos theta minus 1 and B, hence.
So basically, do I need to do 3 cos theta minus 1 equals to minus 3?
Yeah.
And that'll be That would be minus cos theta is equals to minus 2 over 3.
Mm-hmm.
And do I now need to do something like let A equals to cos theta?
It's just 1 theta by itself, so you just solve it.
Okay, so I need to do arc cos of minus 2 over 3.
Yep.
I got 131.8.
0.8. And additional answer between 0 and 360.
So because it's cos, is that 360 minus 131.8?
Yeah.
I got 228, yeah, 0.2.
Grand. No idea what this is about. It's not what I thought it would be. Cos squared half theta is 1 plus. So cos squared of a half theta is the same as a half plus cos a half theta. Hold on. Maybe cos a half theta, the whole thing squared. Nope. Who knew? All right. Any questions about that?
No.
It's not what I thought it was. It was one weird question. I'm not worried. Okay, new thing. Yes. I have a lesson thing for this. Yes, I have a lesson made for this. Do I try bookie way? No, that. Okay. This one. How would you solve the first one?
Would I start off by doing sine x plus 30 equals to a half?
Yep. And then?
Because is that like sine A plus B?
Yeah. You could also just let x plus 30 be a, and then just arc sine.
Yeah.
And swap it back. You could do the same with part B. How would you do part C?
Would I need to first of all make them all the same? So like whether it's so, for example, if I made sine into cos.
That's only if it's cos squared and sine squared.
Should I just say that x? Should I change just all the x's to
a? That's only if it's something x. Like if you're just changing x to a, it doesn't really change anything.
Oh yeah.
1x, 1a. How do you solve it if you have a mixture of sine and cos?
Divide everything by cos.
Yep. To change it into tan, you divide everything by cos, and you get 3 plus 4 tan x equals 0, and then you'd solve that.
Yeah.
All good. How about this one?
So yeah, if I just could I divide it by cos x again?
So if you try that, you would get 3 tan x plus 4, but then you would get 1 over cos x, which is sec x. So you still have a mixture of tan x and cos x, didn't work out. If you were to draw the graph 3 sine x plus 4 cos x equals 1, y equals 3 sine x plus 4 cos x, what is the amplitude? So what does it go up to?
5.
Yeah. And okay, and it repeats every 360. Period of 360. Let's see. Notice any connection between the numbers and the answers. So 3 and 4 gave us an amplitude of 5. 5 and 12 gave 13. 7 and 24 gave 25. 1 and 1 gave root 2.
So was it just one? Was one just added to every single one?
24, 25, 1, 1, root 2. Definitely not the last one.
Yeah. Yeah.
It is Pythagoras. Or the last one. The amplitude is the hypotenuse. So square root of 3 squared plus 4 squared is 5. Square root of 5 squared plus 12 squared is 13. Square root of 7 squared plus 24 squared is 25. And square root of 1 squared plus 1 squared is root 2. Pythagoras. Let's see. That just shows it's a transformation. Use the fact that sine x plus alpha, the equation of the Gaussian plane of RP is identical to this. Okay, let's expand this using our identity. What do we get?
So, do I have to do root 2 sine? Oh no, or even, root 2 sine x cos 45 plus cos x sine 45.
Yeah. What is cos 45?
I'm gonna check. I'm guessing it'll be something like a half or something like that. So
I think it might be root 2 over 2.
yeah, it is, yeah.
Root 2 over 2. Sine 45 will be the same thing. And what is root 2 times root 2 over 2?
Root 2 over 2 squared.
What is root 2 squared?
2. 2 over 4, also a half.
2 over 2.
So would it end up being a half or?
No. 2 over 2.
I'll put into my calculator. So root 2 times root 2 is 2. And 2 times 2 is 4.
It's just root 2 over 2 times root 2. So if you were to expand out the brackets, root
1.
2. Yep. 1 sine x, 1 cos x. And that is what we started with. If I go back to here, so we started with y equals sine x plus cos x. It has been moved 45 to the left. And so that is like sine x plus 45. The Pythagoras is root 2. And so what that shows you is that root 2 sine x plus 45 is another way of writing sine x plus cos x. That's all good. Okay. How about this one? What is the maximum value of this graph?
Maximum value of this graph. So
And the maximum for all of these was the Pythagoras of the coefficients.
oh,
So the maximum was 5 because it was 3 and 4.
I'm not allowed to divide the expression by cos, am I?
No. The maximum will be the length of the hypotenuse if these were the other two sides of a triangle.
So am I doing 2 squared plus 3 squared, and square root of that equals to the max?
Yep.
So I've got root 13.
Root 13. Oh. And the value of x at which the maximum occurs. So how can you find where this maximum occurs?
So this is running to like 360 minus root 13.
Did you say, what did you say, sorry?
Is this running to like 360 minus root 13?
Nope. Let's see. So some value of x gives us root 13. So like if y was equal to that, the maximum y, like height of it, y coordinate is root 13. So we have to figure out what value of x gives us root 13. Any idea how we do that?
So I need to solve for x, don't I?
Mm-hmm.
So shall I times or even
Could try solver.
okay. So with the graphical it was something like solve n.
Yep. And it might work.
How do I get to solve n, sorry?
I think it's like option calc, something like that.
Okay.
Option calc and then F5, yeah, solve n. I'm not sure if it'll give an exact answer or it might give loads of answers because we're talking trig.
And then the solve button is where it's like shift solve.
I think you just press equals for graphical one.
said to me no solution.
That's weird. Okay, so in that case, we need something different, something better. So let's say write, what is this one? 2 sine x.
Oh, I got some answers now.
Is there like a principal value or anything?
Sorry, what does that mean?
Like the one that's closest to 0?
Yeah, I've got one.
What is it?
33.69.
33.69. Okay, so we'll keep that. If we use our double angle formulae, sine x plus alpha, do you remember what that is?
Sine A plus B.
Yeah, like what is sine A plus B when you write it out?
Sine x cos alpha plus cos x sine alpha.
That's it. Sine alpha. Let us see. Match them up. So if I was to write these the other way around, so we have 2 sine x plus 3 cos x. We have cos alpha sine x. We have sine alpha cos x. What matches with what? Notice anything about these?
So is it that cos alpha equals to 2 and sine alpha equals to 3?
Yeah. So sine alpha equals 3. Cos alpha equals 2. How can we get the value of alpha?
By solving
Yeah, how would you solve it?
arc sine of 3 and arc cos of 2.
I'm sure that'll work. You can do it in one go. You can do divide them. Divide 1 by 2 so that you get tan alpha.
Oh, equals to 3 over 2.
Yeah. And so what is alpha?
Alpha is 56.3.
56.3 degrees. Using our Pythagoras thing, we said that r, the number in the front, was root 13. And so it should be root 13 sine x plus 56.3 degrees. Let us see. So I just wrote 56. That's it. Is it? Oh, just wondering if I have the thing. So the maximum is okay. Lots of stuff. The maximum is you would then lots of stuff going on. Yes. I'll just keep it simple for a moment. All I wanted to do was change 2 sine x plus 3 cos x into the sine of something, so it's not a mix of both. To get the r, the number in front, you use Pythagoras for the first two, for the two coefficients. And to get the alpha here, it is the tan of 3 over 2, like the second over the first, the cos over the sine. Sorry, sine over the cos, because they're the other way around. We'll practice it. So let me go back to my other thing. Okay, so we have this one. How would you write this in the form r sine x plus alpha?
So r sine x. Yeah, so r times sine x cos alpha plus cos x sine alpha.
Mm-hmm. And in fact, I'm just going to put the cos alpha at the front. Okay.
Then yeah. Should I expand the brackets?
You can. You can also inspect. So 3 sine x.
Oh, and then 4 cos x.
4 cos x. And if you want, we can put an r. Okay.
And now, is it just going to be like cos x over 3r plus sine x over 4r? Or even will it be so is 3r equals to cos x?
Yeah.
And sine x equals to 4r?
Alpha.
Alpha, sorry.
Yeah. So sine alpha is 4r. Cos alpha is 3r.
And so would it now be tan alpha is equals to 4 over 3?
Yeah.
And then I just need to do arctan of 4/3.
Yeah.
I got 0.0237.
Degrees there, right?
Oh, sorry. I got 53.1.
Okay. So that gets us alpha. We also need r.
So if we do, could I just do could I do sine of 53.1 equals to 4r and then just solve?
Yeah, you could do that.
And so that would be sine 53.1 over 4.
Yeah, and you could do like sine answer if you have it saved.
I got I got 0.2.
It didn't give you an exact answer. Did you use answer or 53.1?
I did 53.4. Oh, sorry. I did. No, sorry. I got 0.199, and it didn't give me an exact answer before.
So we want a quarter of the sine of the answer. A fifth in radians. Shift. I'm going to change to degrees. I think I have to get this thing again. So that's 53.1. I'm getting a fifth.
Okay.
Quarter of sine of answer, where the answer is 53.1.
Yeah.
And so that is a fifth. And so what is this in the form r sine x plus alpha?
So will that'll be 3 times that'll be 3 over 5 sine x plus 4 over 5 sine cos x.
No. Let's see. Let's keep it simple. R is Pythagoras with these two numbers.
Yeah.
So what is R?
So R is 5.
R is 5. Alpha is arctan 4 over 3, which you said was 53.1. And so R sine x plus alpha is 5 sine x plus 53.1.
Yeah.
That's all there is to that. Let me see. Yep. 53.1. R is 5. Yeah. I just want to see the second one, part B. R cos x minus alpha. So we already have R. That was 5. So B, R is 5, I think. Cos x minus alpha. Do you remember the...
No, I don't remember the little equivalent then.
X minus alpha. So that one is cos x cos alpha, and then plus sine x sine alpha.
Okay.
And so match them up. So if I was to rewrite the question, I could write it as cos x times 4 plus sine x times 3. And so what is what?
So do I need to do 5 times 4 cos x plus 3 sine x?
Yep, you could do that.
And so will that be 20 cos x plus 15 sine x?
Yep. Okay. Match up.
So I'm not entirely sure what match up means.
Compare coefficients. So if I was to rewrite it, cos alpha cos x, and that is 20 cos x, you said. The other one, if I was to put them the other way around, sine alpha sine x, and you said that was 15 sine x.
Yeah.
Compare coefficients.
Oh, so cos x is equals to 20 and sine x is equals to 15.
Alpha.
Oh, sorry, alpha.
Sine alpha is 15. Cos alpha is 20. Solve for alpha.
So, this is where I need to do like tan alpha. 3 over 4.
Yeah.
and then alpha will be equals to 36.9.
36.9 degrees. And so 3 sine x plus 4 cos x. What is another way to write that in the form r cos x minus alpha?
So is that going to be r cos 3 minus 4?
No. What is r?
5.
And what is alpha?
36.9.
Yeah, so it's a bit like x minus x1, where one of them stays x and the other doesn't. And yeah, 5 cos x minus 36.9. And my guess is 53.1 plus 36.9 gives us 90 degrees. So two different ways of writing the same thing. So we can write it as sine. So r is always Pythagoras of the coefficients. To change it into sine, it is arctan, in this case 4 over 3. For the second one, it is arctan 3 over 4 to get the alpha. So it's a bit like y minus y1 equals m x minus x1. You just have to find y, m, and x and sub them in, and you keep some stuff. In this case, you just have to find r and alpha, sub them in, and keep everything else. And so, yeah, we can compare using the addition formulae, like something sine x plus something cos x. That tells you that sine alpha is 3, cos alpha is 4, and then you can use that. Any questions there?
No.
Well, practice. Yeah, let me. Okay, match up. Maybe not. Let's see. Okay, match up. Which one would go with which? So, which identity would you use to convert it?
So,
Or which is similar to?
would the first one be sine A plus B?
Yeah, so it's plus, and it's got sine something, cos something.
And so does that mean that the second one would be sine, or even would that be sine A minus B, the second one?
I think it kind of depends which way around you want to do it. Okay, yeah. I just I think it depends what way you want to do it, because it's not very clear. Hang on. Okay. Yeah. This is kind of working in reverse. It's kind of okay. Second. There was this one. It's not quite what I thought it'd be. Yeah, this is what I want, really. Okay, what would be the top one?
So, do I need to do square root of 5 squared plus 2 squared?
Yep.
And that would be equals to root 29.
And so what do you know about writing this in this form?
Is it that r is equals to root 29?
Yeah, so r equals root 29. That's going to be all good, I think. Okay, and then how would you get the alpha?
So I think I forgot.
Alpha will be arctan b over a.
So arctan root 29.
Nope.
Sine x plus a over root 29.
No and no. What is a? What is b?
A is 5.
Mm-hmm.
B is 2.
So arctan b over a?
So arctan 2 over 5.
Mm-hmm.
And that would be 21.8.
21.8. And so what is another way of writing 5 sine theta plus 2 cos theta?
21.8.
In the form r sine theta plus alpha.
So would that be like root 29 sine theta plus 21.8?
Yep. Okay, try next one.
So here would I need to do 1 squared plus, no, the square root of 1 squared plus 2 squared.
Yep.
And so root 5.
Okay.
So r is equals to root 5. And then do I need to do arctan of 202? Do I need to do arctan 2? But I'm not able to do that.
Sure.
And then I'm not sure, and it's going to say to me that there's no answers, isn't there?
You're thinking of sine and cos. Tan graph goes to infinity and beyond.
So yeah, I got 63.4.
Yep.
So will it look something like root 5 sine theta plus 63.4?
Yes. So another way of writing sine theta plus 2 cos theta is root 5 sine theta plus 63.4. Great. Any questions there?
No.
So the r comes from Pythagoras. The alpha thing comes from simultaneous equations of comparing the double angle formulae thing, like one divided by another. So it's just some extra practice. Okay, this one has a minus in between. Let's try this.
So do I need to do square root of 1 squared and minus root 3 squared?
Yep.
I've got 2.
Great.
And so now I need to do do I now do arctan of minus root 3 over 1?
Root 3 over 1. It might be, or it might be the other way around. I'll have to, yeah, try that.
Arctan of minus root 3 over 1.
Yep.
So I'm guessing they want this in radians this time.
Yeah. Says radians, yeah.
I've got minus third pi.
And so, what is another way of writing sin x minus root 3 cos x?
2 sine x plus a third pi.
1/3 pi. Let me just check that one. Minus a third pi. Alpha is pi over 3. I know why. It's because it's because of the minus in between. It's just arctan. Yeah. It's still just arctan b over a. The way to show it would be to expand the brackets out fully. So sine x minus alpha is the same as, I'm going to do them the other way around. So cos alpha sine x minus sine alpha cos x. Oh, is it? Maybe I got that wrong. Is that the formula? Sin x cos alpha. Sin x cos alpha. Yeah, I got that right. And so for the first one, you have 1 sine x, and you have a minus in the middle, and then root 3 cos x.
Yeah.
And so by comparing coefficients, what is cos alpha equal to?
1.
And what is sine alpha equal to?
Minus root 3.
They both have a minus, and so it's just...
Yeah.
And yeah, so that's why it's just root 3 and not minus root 3, because the minus is already there.
Yeah.
And so that's the long way of going about those ones. Okay, so 2 sine x minus a third pi. Hence, sketch the graph of this for part B.
Can I use my graphical calculator?
You could use graphical calculator. I think what they're getting at is it's a sine graph. It's like,
yeah.
It's like where's it, 2 sine something. What will be the maximum and minimum?
Shall I put it into my calculator and check?
It'll be 2. It's got 2 at the front, so it's a stretch of 2 scale factor y direction. And x minus a third pi, what's that going to do?
Does that mean that all x values will go up by minus a third pi? Up by a third pi, sorry.
Yeah, and so it'll be moved to the right by a third pi. Yeah, so instead of it going through 0, 0, it goes through a third pi 0. Instead of going up to 1 and down to -1, it goes up to 2 and down to -2. Yeah. Okay, but big picture, it comes from the double angle formulae, Pythagoras for r, and arctan simultaneous equations for alpha. You can write something that has a mixture of sine and cos into just sine, which makes it easier to graph and solve and stuff. Any questions there?
No.
Okay. Let me see. This is yeah. Just want to see. Okay. How would you do part B?
The calculator.
But how? If you have a mixture of sine and cos, you don't know how you'd get your second answer.
Hence, so do I need to do could I do something different and do like 2 sine theta plus 4 square root 1 minus cos and 1 minus sine squared theta equals to 3?
That would create 2 answers because of the plus or minus for the square root thing.
Right.
How do you get r?
2 squared plus 4 squared square rooted.
And how do you get alpha?
Arctan of b over a.
Yep.
So, and r is 2 root 5.
Okay.
Alpha is am I doing 4 over 2?
Yep.
63.4.
And so we had to solve this.
And so will now be equals to. Oh, I need to get the answer for theta.
So what would this be written in the form r sine x plus alpha?
Or would it be 2 root 5 sine x plus 63.4?
Yes. And now that could go on your calculator.
And so
Do you have it?
I got no solutions.
I got -21.
Okay.
Don't know what. How could you get additional answer?
Oh, you would do 180 minus 21.3,
Mm-hmm.
and that would be 201.3.
And how do we get another answer in our range?
Do I? Uh, I'm not sure how to get the second answers.
It'd be our first one minus 21.3 plus another 360.
So that would be 339.7. Yeah.
I think so. Ew. Wait, alpha was 63.4. Alpha was 63.4. 205. 74.4. What? 338. Sorry, 338.7 is correct. Oh, the other one might not be the principal value? Wait, 74.4. Should be. Shift, sign, answer. How can one be right and the other wrong? That's a thinker. I'll take a look at it next time. Anyway, how was that for you, Andrey?
Yeah, it's difficult.
I will practice it. Any questions for me in general?
No. Is that so? That was 7.5, wasn't it? Or
7.5. Yeah,
okay.
this is 7.5. Yeah. Anything else?
No, that's it. No.
All right. Well done, Andrey. You did great. I look forward to talking to you again later in the week.
Yep. See you on Friday. Okay.
All right. Have a good one. Goodbye.